Hi, my name's Nick Whitelegg. I'm based in Southampton, which is basically on the south coast of England. I work in Southampton University, which is a university there, specifically in the Maritime and Technology faculty. And I'm going to be talking today about basically something very similar to what Alexander's just talked about. In other words, augmented reality applications for walkers and hikers, and in particular on an Android app which I'm currently working on. Okay, bit of background. Well, obviously the traditional map has always been the way in which walkers or hikers have navigated in the countryside, whether that be printed maps or whether it be, electronic maps on your mobile phone or whatever. But it's got, this whole area has got me thinking about whether there are alternative ways. What about actually using the real world and somehow superimposing data on the real world in order to help you navigate? A bit of background to what I want to talk about. Last year in Girona, State of the Map Girona last year, I actually talked about OpenTrailView, which is basically a web application to attempt to recreate a Google Street View-like experience, but for footpaths rather than for streets. Just a bit of background on that. Users take a series of photo shots, stitch them into a panorama, and upload. It is available at OpenTrailView.org. But the issue, I would say, with OpenTrailView is the take-up has been a little slow, and I think that's likely to be due to the barrier to entry, because the whole process of taking a series of panoramic photos, stitching them together with a stitcher like Huggin, for example, and then uploading to the site and positioning them, orientating them, requires quite a bit of effort. It's not too difficult to do, but nonetheless it is quite time consuming, so that could well be a bit of a barrier to entry to OpenTrailView. So in the light of that, and partly because I wanted an excuse to develop a fun Android application, so to speak, I have made a start on this new app, OpenTrail. Okay, so to be honest, I think Alexander has introduced this already, but augmented reality, obviously, is the overlay of basically computer data on real-world data seen through the camera feed of a mobile device. So there are a number of apps already available. For example, Wikitude, which I think actually is an Austrian product. I think it comes from here, where you can overlay. So you can point your camera at a point of interest, like, I don't know, Vienna Cathedral, for example, and it will tell you some information about that point of interest. So those sorts of augmented reality applications are quite widespread, but at the moment there are relatively few which actually overlay ways, or polylines, whatever you want to call them, in other words, routes, paths, roads, and so on the camera view of a mobile device. So, as you can probably already appreciate, this does have a potential use for in-the-field navigation in the countryside. Okay, so this is basically what OpenTrail is. It's an Android app for countryside navigation. Now, the augmented reality is part of it, but it's not the whole story. So it actually shows FreeMap, and just by way of explanation, FreeMap is a countryside-orientated slippy map for the UK countryside, which makes use of OpenStreetMap data and renders things in a colour scheme which is geared towards the sort of subtleties and nuances of the UK rights-of-way system, which is probably quite complicated for those of you who are not from the UK, but that's another story. So OpenTrail does that initially. So if you load OpenTrail, if you get it going, you will just by default see a slippy map, a phone-style slippy map of FreeMap. You can also see out-of-copyright ordnance survey maps as well, and that's very useful if you want to go out into the countryside and find out which paths have not been added to OpenStreetMap yet. But the real thing I want to talk about is the augmented reality view. That's available as a prototype. It's pretty unstable at the moment. I've only really started working on it in the last 3 or 4 months. So it's really just a proof of concept at the moment. But nonetheless, it kind of works. So how does it work? Well, the components are basically the camera feed from the phone, obviously. OpenStreetMap data is overlaid on the feed. Does that sound better? Right, it's not too quiet. Good. OpenStreetMap data is overlaid on the feed. Okay. And freely available height data is taken into account. And what I'm using at the moment, now it's not switched on yet, the code is there, but it's not, the actual feature isn't switched on yet, is Ordnance Survey landform panorama data. Now that is actually part of the Ordnance Survey open data set, because about a year ago, or just over a year ago, the Ordnance Survey from the UK opened up a series, a set of geodata, and that includes some fairly high accuracy height data, better than SRTM. So the idea is to use that, at least in the UK, for OpenTrail. Okay, so they are the components: camera feed, OpenStreetMap data, and height data. Okay, now that's what the aim is to look at, something like that. So a typical use case of this app would be you enter a very large field, and there are lots of these in the UK. Quite often you enter a field at one end, there's a gate at the other end about, I don't know, 1/4 of a kilometre away, something like that. And it's not very clear what the way through the field is. There might be a gate in one corner and a gate in the other corner, but you might not know which way the trail or the footpath goes. So the idea is to have a view something a bit like that, where you can see there's your real world in green and the blue sky, and you can see the OpenStreetMap data overlaid in yellow, and you can see it goes to the gate. So that's what I'm aiming for it to look like. Okay, now how is the OpenStreetMap data dealt with? How do we obtain the data from OpenStreetMap? Well, basically the data doesn't come from OpenStreetMap itself. I load OpenStreetMap data into my own server, the FreeMap server, and I've set up my own web service, which basically delivers data from my own local PostGIS database within a given bounding box. So basically you send a bounding box to this web service, and also a projection. You can tell it which projection you want to get the data out with. And the data comes back as this XML here. Notice it's not standard OSM XML. It's actually basically, you could think of it as an XML representation of the PostGIS database itself. So you can see away doesn't contain a list of OpenStreetMap IDs. It instead contains a list of coordinates, and that's a lot easier to render because you don't have to get the IDs and then look at the nodes with those IDs to get the coordinates. Plus, obviously, with it being a PostGIS database, they're stored as nodes and polylines anyway. So basically, my web service delivers OSM data in that format. So the app asks for only data with a highway tag. So you'll only get back data with a highway tag because at the moment, I'm not interested in any data which doesn't have a highway tag. Okay. So the world is divided into a series of approximately 5 kilometre by 5 kilometre tiles. So the idea is if you're out walking in the countryside, every time you enter a new 5 kilometre by 5 kilometre tile, then a new request is sent to the web service. The web service delivers the data in that XML format. That data is parsed, and the XML tile is cached on the device, so that next time you're in the same area, you don't have to download the data from the network. The data will just be obtained from the cache. Okay. As I said, there is also height data to take into account because, as Alexander pointed out very clearly, you don't, obviously, if you're in a very hilly area, and southern England isn't that hilly, I mean, it's hilly but there aren't mountains, it's less important. But obviously if you're somewhere like the Austrian Alps, then it's extremely important. So you want to overlay the data so that, obviously, if there is a mountain in the way, the path will be overlaid on the mountain as opposed to burrowing straight into the mountain, which would be no use to anyone. Okay, so that's what I want it to look like eventually. Very similar sort of a drawing, very similar to Alexander's actual picture of that mountain outside Salzburg. So you can see the idea is to show the paths going up the peaks, something like that. Okay, so the facility is actually implemented. Now, as I said, as you'll see later on, there are still some issues that I need to get sorted out. So until I've sorted out the issues, then the height facility won't be switched on. It is implemented. It's only really just uncommenting a line of code and it will be switched on. Basically, the height data is part of the Ordnance Survey Open Data package, the landform panorama data set. In other countries, something like SRTM, the NASA SRTM data set could be used. The landform panorama data set is pretty accurate. It's 10-meter intervals, so basically height is sampled every 10 meters. So it's pretty accurate. So that the idea is you load the data in from the web service. You also request from the server, again, a 5 kilometer by 5 kilometer grid, 5 kilometer by 5 kilometer tile of this Ordnance Survey height data. And then the height data is used to give the OSM data a Z coordinate on the device. So the cached data will, once this has been turned on, include the Z coordinate so that you don't need to do that calculation. In other words, the Z coordinate of the Ordnance Survey data, OpenStreetMap data later on. Okay. So basically, the idea is you download the OSM data as a 5 km by 5 km grid. You download the height data as a 5 km by 5 km grid. You use the height data to give the OSM data Z coordinates, and then you cache that on the phone. Okay. Right, now what about the actual augmented reality itself? Now, obviously we need our current position. That's pretty fundamental. And we get our current position by using the Android location APIs. They're very well documented, loads of information about those. Reference there, which just is the API docs for that. So getting your GPS position is very easy using the Android location API. What we also need to get, obviously, is the orientation of the device, because obviously, we can, with a smartphone, we can rotate it around like that. So the orientation is going to be the azimuth, which is the angle, the bearing, basically, that the device is facing. And we've also got to take into account the pitch, in other words, whether it's pointing up, whether it's pointing sort of diagonally, or whether it's pointing down, like that. So basically, we use the sensor API to get use the compass and the accelerometer to get the bearing and the pitch. And from that, we actually get a rotation matrix. So the sensor API gives us a rotation matrix, which represents the rotation from the phone in standard orientation to the actual current orientation. Okay. Right, so that's just a bit of a diagram there showing the pitch and the azimuth, but I've kind of already demonstrated that by hand. Okay, what about the actual rendering of the OpenStreetMap data on the camera feed? Well, as Alexander did, OpenGL is used because obviously, OpenGL is the standard 3D API for non-Microsoft platforms. And obviously, we're dealing with data in a 3D space, so OpenGL is the natural choice to use because it means that a lot of the heavy maths is really done for us. Now, as those of you who have worked with OpenGL should know, OpenGL defines something called the model view matrix, which describes the relation between the 3D world and our current view of it. So basically what we can do is use that matrix that we got back from the sensor APIs in order to use as the OpenGL model view matrix. And if we do that, then basically the rest almost magically happens. Okay. So that gives you an overview of how it works. Now, there are a few issues remaining, basically, it's kind of working, as in there's a demo version working. I've done a bit of testing. Last weekend I was walking around some countryside fairly near where I live to give it a bit of a test, to give it an idea as to how good it is. And the main issues so far are inaccuracies in the underlying OpenStreetMap data, instability of the compass, though I have implemented a bit of exponential smoothing following the advice of some articles on augmented reality that I found on the web, and an inaccurate horizontal field of view angle. They are what I would consider the main issues at the moment. Now, inaccuracies in OpenStreetMap data, then really what you really need to be doing there is mapping, basically. So if you're mapping the countryside, don't just map your footpath once, map it over and over again, and so that you can improve the accuracy of the course of the footpath by taking the average of the GPS traces rather than just one. So inaccuracies in the underlying OpenStreetMap data, they don't really make much of a difference in a printed map, because obviously, you know, if it's 10 meters out, it's not going to make much of a difference in a printed map. But if you're dealing with something like augmented reality, then the path is going to shift much further away from where it should be, so that's much more of an issue. Something else which I haven't mentioned there, but which is a fairly obvious issue, is GPS accuracy, because obviously if the current accuracy of the GPS on your phone is a bit out, then obviously the data is not going to be rendered properly. So in woods and forests, then this sort of app is probably going to be a bit difficult to use. Instability of the compass and inaccurate horizontal field of view angle. About the field of view angle, now Android 2.2 Plus does have an API call for that, but unfortunately it's not available in this, which is Android 2.1. Basically, another OpenGL API call, or it's more specifically the Glue library API call, is Glue Perspective. That allows you to easily set up the perspective, which we've already seen is pretty important if you want to get an accurate view. But the only thing is that Glue Perspective needs a vertical field of view angle. Now, we can get a vertical field of view angle easily from a horizontal field of view angle. The only trouble is that there's no way of getting either of these from the 2.1 API, and worse, the specs from this particular manufacturer for this particular phone don't give us the horizontal field of view, or the vertical field of view, or the focal length, or any of these specifications that would allow us to get that. So basically, I did guesstimate it by using a stone circle in England to estimate the field of view angle. But really, probably manual calibration may well be necessary so that the user can align the augmented reality view with somewhere they know so that they superimpose. So I may well just go along the route of manual calibration for that. Okay. The other issue, sort of running out of time now, so best be quick. The other issue is an implementation issue. Basically, the way I've done it involves overlaying the camera, a surface view containing the camera feed on the OpenGL view. So there are basically two surface views, one on top of each other, for those of you who have done some Android development. But apparently you're not supposed to do that. You can't reliably overlay surface views on top of each other, according to a Google employee, where there's a reference there. So basically I'm going to have to work on a different way of doing it, which will probably involve looking at how GL surface view was implemented and trying to implement that myself, re-implement that myself, so that I just use one surface view containing the camera feed and then the OpenGL data on top of that. And I have put in to present on this in Denver, so I do hope to have one of those done, ready for Denver. Okay, some references as to how you can get it there. If you want to take either of those down. This talk is available on the internet, by the way. There is an APK, but that doesn't contain the augmented reality. The only way you can get the augmented reality version is through source, basically via my SVN repository, and that's because it is a bit unstable at the moment, so I don't want to just let it loose on the public, so to speak. But there is, if people are interested in this, I have pre-downloaded the data for Vienna. So if there is interest, I can arrange a demo in the Wrestle Park outside. And I have tested it in the Belvedere Park. It works reasonably okay. So if anyone is interested, do let me know. OK, thanks. Any questions?
We have time for 1 or 2 questions. Where are they? Yeah.
You said you're overlaying height data that's from a different source onto OpenStreetMap data. On one hand, what are you doing with any points that actually have height data in OpenStreetMap? On the other hand, what are you doing with tunnels and things like that?
To be honest, tunnels is something to be honest, tunnels isn't something I've thought of yet, really. That's a very subtle thing which will come later on. So you're talking about actual nodes in OSM which have got a height data already. I'm not doing anything about that yet. Obviously, if it's a mountain peak, then obviously I could parse the height data and do that. So yeah, that's something useful. That's something useful which I could do. It could be done pretty easily, but I don't do it yet. Okay.
Any other questions? Okay, then thank you, Nick.